Chapter 16, Scheduling. So scheduling is establishing the timing of the use of equipment, facilities, and work people do in an organization. So if you schedule effectively, you can save cost, increase productivity, and achieve other benefits, things like employee satisfaction. So here is an example of a load chart where there's work centers 1, 2, 3, and 4, and you're putting different jobs in different work centers on different days. So in this example, on Monday, you're working on job 3 in work center 1, job 1 in work center 3, job 10 in work center 4. So it's a way of laying it out, and you've probably seen this if you've ever worked like in a fast food restaurant or scheduled someplace. That they'll lay out, or in a hospital, the staffing schedule. They'll lay out. This is who's working when. This is what they're working on. This is an example of that's a load chart. It's pretty common. So there's two loading approaches. One is infinite loading. And so this is normally how you lay out jobs, is you start out with infinite loading, where you just say, I'm just going to start putting the jobs down. And in this case, with infinite loading, on this day, you are over capacity, and on this day, you're over capacity. So then finite loading tries to level that out. So in this case, your capacity is right here, and where you go over capacity, it just spills over into the next day, such that right here, you notice this one is filled up, and that effort is really filled up by this overage that was on day 2. But now you get to day 5, and this part is low because you can't start on this overage until here. So this overage up here is really going into the following week. So there's scheduling approaches. One is forward scheduling, where you start out with some point in time and you say, how long does it take to complete this job? And you just work out all the time, work out the schedule until you get to the end, and that's how long it takes. Then there's backward scheduling. So this answers the question, when is the latest this job can be started and still be completed on time? So it's really the same kind of thing, except that you're starting at the due date and working backwards. So here's a schedule Gantt chart where you have different activities and different stages in the project. So you start out with approval of drawings, and from there it goes to the site preparation. You order trees, you order shrubs, and then they come in. Here's receiving. Now you plant them, you receive the shrubs, you plant them, and then you have final inspection here with approval. So that's an example of a Gantt chart for schedule. So there's a couple of methods for assigning work. One of them is the assignment model, which uses linear programming for optimal assignment of tasks and resources. The other is the Hungarian method. And this is a one-for-one matching to identify the lowest cost solution. So there's sequencing, and this is where you determine the order in which jobs at a work center will be processed. So there's priority rules. So one of them is the simple heuristic used to select the order in which jobs will be process. The rules generally assume a job setup costs and time are independent of processing sequence. And the job time is really the time needed for setup and processing the job. So there's different priority rules. Probably the most common is first come, first serve. So a job comes in, and whichever one came in first, you start working on first. There's this other one which is shortest processing time. And so when you use shortest processing time, you might see this sometimes when you're in line. So normally when you're in line, that's first come, first serve. But you get up to the counter and the person says, you know what, the person behind you only has one question. Or someone will actually cut line and they say, I just have one question. And that's really like a shortest processing time interrupt there. Another is earliest due date. So in other words, you just you start working on the one that's due first. This is something you might do with your homework. So yeah, the assignment last week was assigned, but I have a different class that has a due date tomorrow, so I'm working on earliest due date. Then there's critical ratio, slack per operation, and then rush. So this is the you're using one of the methods above, and an emergency comes in, a priority customer or whatever, and it just sort of goes to the front of the line, takes cuts in front of other people. So there's some assumptions with priority rules, and the set of jobs is known. No new orders arrived after the processing begins, and no jobs are canceled. Another assumption is setup time is independent of processing sequence. Setup time is deterministic. Processing times are deterministic. In other words, you know what they are. And there will be no interruptions in processing, such as machine breakdowns or accidents. So, so some of the common metrics with sequence, job flow time. So it's the amount of time it takes from when a job arrives until it's completed. It not only includes the processing time, but any wait time to be processed. So job flow time, we measure that all the time. It took me, I went to the doctor and it took me 2 hours and I only saw the doctor for 5 minutes. That's job flow time. So from the time you got to the doctor, you filled out some forms, you waited in line, and then you went to, they finally put you in a room, and then you talked to a nurse, they took your blood pressure, and then the doctor came in, and then the doctor ordered some tests, and then you had to go have those tests, and by the time you were done, it was 2 hours. So that's job flow time. Job lateness. That's the amount of time the job completion time is expected to exceed the date the job was due or promised to the customer. So, the guy who took the order, the lady who took the order said, we can have it done in a week. Great. You plan it for a week, and suddenly, you didn't make it. So you could go through and just measure how many of my jobs are on time, how many are late. And then there's make span. This is the total time needed to complete a group of jobs from the beginning of the first job to the completion of the last job. So make span is really, I have an order for a customer. We have multiple things that are going through the factory. We're going to ship them all at the same time on the same truck. So then, so how is that going to work? So that's a make span. So you have a group of jobs. And then average number of jobs. Jobs that are in the shop are considered to be work in progress, or WIP inventory. So that's another measure. So here's a two work center sequencing. So there's something called the Johnson's rule. This is a technique for minimizing make span for a group of jobs to be processed on two machines at two work centers. It minimizes idle time, and several conditions must be satisfied. So here's the rules, the Johnson's rule condition. The job time must be known and constant for each job at the work center. Job times must be independent of sequence. Jobs must follow the same two-step sequence, and all jobs must be completed at the first work center before moving to the second work center. So, the way you use Johnson's rule, first you list all the jobs, their times at each work center. Select the job with the shortest time. If the shortest time is at the first work center, schedule that job first. If the shortest time is at the second work center, schedule the job last, and you break ties arbitrarily. So then you eliminate that job from further consideration, and then you repeat steps 2 and 3, working toward the center of the sequence until all jobs have been scheduled. Okay, so now we're going to talk about theory of constraints. There's this book called The Goal, and this is sort of a classic. It's written as a novel. Alex Rogo is a plant manager. He has consistently late deliveries. The plant will be closed in 90 days unless performance improves. Hundreds of people's jobs are on the line. And he goes through this process of really explaining the theory of constraints as part of this novel. I'd recommend this book to read. You can also, if you just YouTube this, there's actually there's a video that goes with this, but it's like a sample piece of it, but it gives you a little bit of a sense of the story. But it's sort of the classic theory of constraints book. I did not require this because I didn't want to make you buy another book, but a lot of operations management classes just have this as required reading. So the theory of constraints, it's a production planning approach that emphasizes balancing flow throughout the system, and it really pursues a perpetual 5-step improvement process, and it's centered around the system's currently most restrictive constraint. So the bottleneck operations limit the system output. So wherever there's a bottleneck, you schedule the bottleneck operations in a way that minimizes their idle time. And then there's this drum, buffer, rope. So the drum is the schedule. Buffer is potentially constraining resources outside of the bottleneck. And rope represents the sequencing of the synchronizing the sequence of operations to ensure the effective use of the bottleneck operations. So one of the things is that by varying batch sizes, you can achieve output, the greatest output of the bottleneck operations. So there's process batch, which is the economical quantity to produce upon the activation of a given operation. And then there's transfer batch. It's the quantity to be transported from one operation to another. And it's assumed to be smaller than the first operation's process batch. So here's how you improve bottleneck operations using the theory of constraints. First, you determine what is constraining the operation. You exploit the constraint. In other words, you make sure that the constraining resources is used to its maximum. So it really, the bottleneck becomes the priority. You subordinate everything to the constraint. You focus on the constraint. You determine how to overcome or eliminate the constraint. And then you repeat the process for the next highest constraint, because as soon as you eliminate this bottleneck, a new bottleneck will form. So there's three things are important to the theory of constraint. First is throughput, the rate at which the system generates money through sales. The second is inventory, and inventory represents money tied up in goods and materials used in the process. And the third is operating expense, all the money in the system spends to convert inventory into throughput. This includes utilities, scrap, depreciation, everything. Okay, so service operation has its own set of problems. So it's a special, it's not found in manufacturing. So there's two reasons for this. First is you can't store or inventory services. And then the second is the random nature of service request. So service scheduling may involve customers, workforce, and equipment. So there's some things you can do with the customers. So one of them is demand management. So an appointment system controls the customer's arrival for service. So I mean, this happens with your car, happens at the doctor. You call up and say, I want an appointment. I want to come see the doctor, and you make an appointment. So then there's appointment systems. There's the reservation system. So with these systems, if you have a good feeling for when the demand is, so the difference between a reservation and an appointment, a reservation is not necessarily constrained. Just tell me when you want to come, and I will ramp up to meet your reservation. Appointment is more like, this is when you can come. Would you like to come then? And then, so that's one place, is to focus on the demand. The second is scheduling the workforce, which is sort of a capacity management. So there's cyclical scheduling, where employees are assigned to work shifts or time slots and have days off on a repeating basis. So you can manage capacity that way. So the summary, we talked about the loading approaches, infinite loading, finite loading, scheduling approaches, forward scheduling, backward scheduling. We talked about Gantt charts, priority rules, two work center sequencing, theory of constraints, and scheduling service operations.